All right, let's talk angle of elevation, angle of depression. I hope your angle of depression is small today. Okay, so angle of depression and angle of elevation, all you have to know is that, let's say you are standing right here. When you look out directly from your eyeballs, that is called your line of sight. And if you have to look up to see something, that's called an angle of elevation, up. So let's say you see an airplane. Oh, this is going to be bad. You see an airplane up in the sky. Oh gosh, that doesn't look like an airplane at all. That's okay. That would be your angle of elevation. And then if you're looking down at something on the ground, say maybe like a bush or a flower, pretty bad. This would be your angle of depression or down. So just keep in mind that you're always looking up for an angle of elevation from your line of sight or down for depression from your line of sight. Okay, let's do a problem with this. I think question 7 is angle of elevation and depression. I lied. It's question 8. Okay. So first let's scan and see if we should be in degrees or radians. I see a degree. We should definitely be in degrees. Okay. The following diagram shows a pole BT 1.6 meters tall on the roof of a vertical building. The angle of depression from T to A, so we're looking out straight from T, the angle of depression down to A is 35 degrees. And then the angle of elevation at the top of the building from A, so something that looks like this to the top of the building, is 30 degrees. Okay. Find the height of the building. So the height of the building over here is this guy. So I see that this here is 90. So if I did 180 minus 90 plus 30, I should get the remaining degrees up here, which is 60. That might be helpful. And then I see that up here, this is a right angle. So if I do 90 minus 35, I have the remaining degrees left in this angle. And I'd like to relate this skinny little triangle, because that's what I know the most about, to this bigger triangle over here, so I could ultimately find the height of the building. So I'm going to try to find x first, then use x to find y. Okay, so I'm going to kind of isolate this little skinny triangle. What is my thing doing? I'm going to isolate this skinny little triangle right here. It looks so bad. Okay, that's fine. This is 55 degrees, and that is across from the side length x that we want. And then, let's see, I have 30 and I have 35. Okay, so these are going to be equal because they're alternate interior angles. So that means I've got 5 degrees left right here for this skinny little angle. Okay. And then this is 1.6. Okay, so across from here I've got x, across from here I've got 1.6. I'm going to use law of sines. So I've got the sine of 5 degrees goes to 1.6 as the sine of 55 degrees goes to x, and I'm going to cross multiply. So the sine of 5. Okay, so I have x is equal to this divided by this. All right. Okay, so, ooh, excuse me. That's the bell, 0379. Okay, so that guy is across from 90. And then this guy is across from 30. So now I have this times the sine of 30. All right, divided by the sine of 90, which you should know is 1. So I would get y is equal to 7.52, what is it, meters? Meters. Cheers.